a lot. All right, let's take a look at our spell work up here. These are all review. We've done things like this all year. So, what do we do on this one? Yeah. Our thing with the power is already by itself. It's already isolated. So I want to get rid of the square, and we do that by square rooting. When I square root both sides, my square and my square root cancel out. So we get our x plus 2 equals...
Plus or minus.
Good. We square root of both sides, so that means we put our plus or minus 5. Which means when we're finding all of our possible solutions, I need to split this to have a plus and a minus. So we're going to have our x plus 2 equals positive 5, and our x plus 2 equals negative 5. Which means what are our two solutions?
3 and negative 7.
We subtract 2 from both sides. We get x equals 3, x equals negative 7. Less. Boop. There we go. Making it a little bit bolder. Those are our two solutions. How about the one on the right? We haven't seen one like that in a very long time. What do we need to do over here first? Super close. I was like, we need to deal with the plus 2. In order to deal with it, we're going to subtract it. I want to get my absolute value all by itself first. I need my weird operation to be by itself. So I've got my absolute value of x minus 3 equals 4. Now what do we do? What do we do with these absolute value things again? They are kind of like parentheses, so it's why we get it by itself first. Does anyone remember what an absolute value really tells us? We're going to split it because it's all about the distance. X minus 3, that set, is going to be 4 steps from 0. So it could be that it exactly equals 4. We love that. The absolute value bars might just be decorative. And x minus 3 might just equal 4. Other option being x minus 3 is 4 steps the other direction, which would be negative 4. So absolute values are all about our distance. It is that many steps away. So x minus 3 could equal negative 4. Let's finish it out. What do we do to finish solving these out?
Plus 3.
Plus 3 on both of them. So we're going to have our x equals 7. And x equals negative 1. And those are our solutions. And I am too hot to stand right now. I have to sit down because this is way too many layers of clothes for a 50-degree day. Whew. I'm going to melt. That would be the wrong show. To be a witch that melts, yes. What's up? Yeah, you're going to pass. Okay, so we have a little bit left to do in Unit 6. Questions on this spell work. Okie dokie. So I'm putting up here some steps that we are going to use today. If you are one of those people that loves a checklist, great. It is shockingly similar to when we did absolute values and solving our square roots. It is a very, very much the same steps where we are isolating our specialty function. We are going to deal with the power, and then we solve it. We may have to split it. We might not have to split it. Oh, fixing. There we go. Oh, I was really like, who's the other one who came in late? Yeah, my boss. Yeah. I was making sure that the attendance popped in. I was like, I only had one pass, but I know 2 people came in. Yeah, because I was a grown-up. All right, so we're going to isolate, deal with the exponents, and then we're going to finish our solve. So we've solved things very, very similarly. And in fact, our square root that we did in the bell work is very, very similar to what we're going to be doing today. So I'm going to give you just a smidge more time. Never mind, nobody's writing anymore. So let's just get into it. We are going to figure out what our terms are going to be here. So I've got the square root of x is 3. What might x be on the first one?
3.
The square root of what?
Square root of 9.
The square root of 9 is 3. What we do to solve these, when we have a square root, remember it has that invisible index of 2? So in order to get rid of that square root, we're going to take that same index as our power. We're going to square it. But whatever I do to one side, I have to do to the other side, so we do that over here as well. So my square root and my square cancel out, leaving us with just x. And 3 squared gives us 9. Now we do need to, in our radicals, in our square roots, check and make sure this doesn't make us have an imaginary answer. We're not doing imaginaries here. So we need to make sure what's under the radical does not become negative. So, since x is a positive 9, this is fine and this checks just fine. But all we need to do is make sure that whatever's under the square root is not negative, as long as it's an even power. Which we are only dealing with even powers, so we're good. Let's look at the one on the right. It's a very similar process to what we did in the bell work. I need to get my specialty piece. I need this guy by itself first. So if I need to get my square root of x to be all by itself, and I have 2 square root of x minus 4, what do we need to do first? Add 4. Perfection. I'm adding 4 to both sides of my equation. That's going to give me 2 times the square root of x equals 4. I still want to get this square root all by itself, so I would like to get rid of that 2. So let's divide both sides by 2. We're going to have our square root of x equals 2. And then what do we do? We're going to square it. Yep, we're going to take it to the power of 2, or we're going to square it. It's already being square rooted, so we want to undo the square root, and that's how we square it. So my square root and my square cancel out, leave me with just x over here equals 2 squared, which is 4. And again, we're going to look back at our original equation and make sure if my x is 4, do we get an imaginary number? Nope, so that's good. So we have checked and we're good. Literally all we care about is do we have a negative under the square root? That's it. Questions on either of these two? What's up?
Have you seen the freshman cafeteria yet?
Oh, the decorations for Russell?
Yeah.
No, I have not. I was not paying attention to my walk past this morning.
Did it Saturday.
Nice.
And turns out my waiver for 10th Peter can go for this. So I was like the only kid up on ladder, so it was amazing.
Nice. All right. So here's our next two. Now I've got the square root of 2x plus 5 equals 9.
I don't know why I put plus and minus.
What's up?
I put a plus when I was trying to minus 5.
Ah, so you were figuring out our first step, which is to subtract that 5, because that's absolutely what we're going to do. We're going to minus 5 from both sides, because I want that square root all by itself. I got my square root of 2x equals 9 minus 5 gives me 4. What do we do next? Square it. We're working basically from the outside in. So at this point is when we're going to square it on both sides. Because all I have left is my radical. I don't care what's under it. So if square root and the square cancel out, and we're left with our 2x equals 16. So what do I do to get my x by itself? Divide by 2. So what's my x equal? X equals 8. Is that an okay thing to have in my radical, or is it going to give me a negative underneath? If my x is 8, is that good, or are we going to get imaginary? It's good. Cheek. So we're just checking to make sure we don't get a negative under the square root. That's the only time we have a problem. Okay. One more little one before I kick it up a little notch. So we got the square root of 3x minus 5, and then plus 2 equals 6. So what are we going to do first? Gorgeous. Minus 2. So we're going to have our square root of 3x minus 5 equals 4. What's going to be next? Square it. Yes. We want the square root all by itself so that we can square both sides to be rid of it. So we're going to be left with our 3x minus 5 equals 4 squared, which is 16. And then what? What are we going to do next here? Plus 5 would be the way I would recommend. I was going to say, there are several pathways through from here, but honestly, if you add 5, you'll wind up with no fractions. So I do recommend doing your adding and subtracting first. So I'm going to add, bless you, add 5 to both sides. That's going to give me 3x equals 21. One last step. Gorgeous. Divide by 3. So my x is 7. Woohoo! So it's slightly different than the other solving things we've done. But honestly, it's so very similar to other solving things we've done as well. So it's definitely a different function. We've not done square roots, but we have square rooted when solving before, so it's real similar. Sometimes they look a little different though.
Oh God.
What does a fraction in a power mean? What is a power of 1/2? What does that mean? It's the square root. Remember, this is our index. If it has a denominator, that's the index. This is 100% the exact same thing as saying the square root of 13x minus 4 plus 8. That is what the fraction indexes mean. That's what the fraction powers mean. The denominator of the power is the index of the root. So 3x or 13x minus 4 to the first is under my second root. So it's the same exact process. We just sometimes will write it as a fraction root, sometimes we'll write it in a radical form. You do not have to switch it like this. You can keep it just like this and deal with it the exact same way. It will be 100% the same steps. It's just a matter of how you like to write it. But I know that the roots are a little bit more familiar to us because we've seen them before. So if we're more comfortable with the roots, put it as a root. Totally fine. Either way, whichever way you write it, subtracting 8 is going to be your first step. So we're going to have our square root of 13x minus 4 equals 10. I would say whether we write it as a square root or to the power of 1/2, what are we going to do next? To the power of 2. We're going to square it. And we square both sides. I'm going to put a little example over here. These really like right. So if I kept it as the 13x minus 4 to the 1/2, and I raised it to the power of 2, we would still wind up with an exponent of 1 on the 13x minus 4. Because 1/2 times 2 would be 1. So it gives you the same thing, whether you put it as a fraction or as a radical. Either way, you get the same piece. So we're going to wind up with our 13x minus 4 equals, what's 100? 10 squared. Then, yep, plus 4. So we're going to have our 13x equals 104.
What?
What's that?
Oh, Marley.
Don't say don't forget to square the 10.
We subtracted 4.
Oh, yep.
Add 4. X equals 8. Yeah, look.
It's already got a minus on it, so we need to add it. And yes, you are right. Because we're going to divide both sides by 13.
Bruh, you really just messed up the stuff.
So our x equals 8. Which still gives us a positive value inside our radical.
Oh, no,
Okay, so the fractions will show up sometimes as powers, but all that is a square root or cube root, whatever it says there. Here's our next one. What is going to be our first step here? Plus 9. Good. Again, not the only choice, but definitely the easiest. So we're left with our 4 square root of 2x plus 6 equals 12. Then what?
Divide by 4.
Divide by 4. That 4 and that 4 will cancel out, leaving with our square root of 2x plus 6 equals 12 divided by 4, which is 3. Squaring the square root, square both sides. Oh, that's too close. Square both sides, because then the square and the square root cancel out, and we're left with our 2x plus 6 equals 9. So next we minus the 6 to get 2x equals 3. How do I get my x by itself? I already did minus 6. Yep. No worries. Divide by 2. X equals 3 halves. X equals 1.5. X equals 1.5. However you want to word it. But we will sometimes wind up with fractiony answers. And that's okay. There's going to be times when they get fractiony way earlier on. And that's okay too. We still want to make sure that that does not give us a negative inside our square root. That would still be positive, so we are good to go. Questions on this one? Okay. This one looks super icky.
Yeah.
So I've got the square root of 7x minus 2. And we want to know when that equals the square root of x plus 3. What can we do?
Square root.
Yeah, square the square roots. I've got square roots on both sides, and they're both already by themselves. So let's just do that. Square both sides. This square root and that square root cancel out. This square root and that square root cancel out. So we have our 7x minus 2 equals x plus 3. So what do we do here? Guys. Alex. You loud dude. Minus the x on both sides. We only have one more after this one. We're going to have our 6x minus 2 equals 3. What else do we want to do? Add the 2. So we've got our 6x equals 5. Divide by the 6. And we're going to have x equals 5/6. And again, we'd wind up with something that's not going to give us any negatives anywhere when we substitute it in. So we're good to go here. So that one checks. We're checking to make sure we don't get any negatives inside the radicals or that the radicals don't equal something negative. So if it has 2 square roots, we're not usually so mean that it's going to make it super gross and you have to do extra steps. So it should be able to square both sides just like this. One more. Last one. So we've got the square root of 4x plus 13, and we want to know when that equals x plus 2. Yeah, our square root is already by itself. So we don't have to do anything to get it by itself, so we're ready to square this side. But that means we also need to square this side. So we're going to come through and we're going to square this, just like we have been, and this. My square root and my square cancel out over here, so we're left with our 4x plus 13 equals, and we need to do x plus 2 as a quantity squared. So that's the same thing as x plus 2 times x plus 2. Box it, distribute it, whatever method you choose, multiply it out fully. So we're going to have our 4x plus 13 equals, we're going to have our x times x giving us x squared. X times 2x is 2x. X times 2x is 2x. I have 2 of those, so we have a total of 4 x's plus 4. However you choose to multiply it out, whether it's distributing, whether it's boxing, whether it is a different kind of multiplication, FOIL, however you want to do it. Then what should we do? When I have an x squared and we're trying to solve, this is what we did in the last chapter. How would I solve this? When in doubt, when I have x's on both sides of an equal sign, get our x's together. So my first step that I'm going to do is I want to get my x's all on the same side. So I'm going to subtract this 4x from both sides. Minus 4x, minus 4x. When in doubt, get all your x's together and see if that helps us figure out what we should do. That gives me 13 equals x squared plus 4. Does that help us figure out what we want to do? We can absolutely subtract 4. That gives me that 9 equals x squared. And now we can square root both sides of the equation. It's early, fully valid. So we're going to have that our x equals what? But when we square root both sides, we have to include a plus or minus. All right, so if we chose the positive 3 as our answer, because we need to check both of those. So if x equals positive 3, what's under the radical is positive, definitely, because it's all positive things being added, and it's set equal to 5. 3 plus 2 is 5. So this one checks totally fine, easy peasy. If x equals negative 3, and we substituted that in, 4 times negative 3, we'd have negative 12 plus 13, so this would be the square root of 1. Negative 3 plus 2 is what? Negative 1. Does the square root of 1 equal negative 1? Because can square roots equal negative numbers? No. So this one is not a valid solution. Ooh, pulling up an old school vocab word. We did it in our quadratics chapter. What does it mean when they make us do all this extra work and it's not even a solution for us? Oh my God. It's so extra. It's extraneous. Good, 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 good. I was like, you don't have to be able to pull that word up on your own, but just putting it back into our brains. Oh, snap. Okay, so it's not going to be super common that we have extraneous solutions like that, but it can happen every now and then. So that is why it's important that we check as we're going to make sure we get things that are valid. Okay? Questions on this one, because this one's the hardest one of them. There's one. Okay. That is officially the end of notes for the semester. And this, I'll hold in my hand right here, is the last homework of the semester. On down. You can do this. Have fun. Have fun. Okay. So we're getting real close to the end here, guys. This is our last full week. Thanks, baby. Y'all are only here Monday.
Bye, baby.
This is the last one of the semester. Everything after this is reviews, which I will always give you points for, but I don't put points against you if you don't do them, because they only help.
I love how on days that I have to get up like really early, my body doesn't want to wake up. And on the days that I don't have to wake up, like I can wake up whenever I want. I decide to wake up early. So
Yep.